This recording is for Primary Math 3. We're in the Workbook 3A on page 12. No, I'm sorry, not page 12. It's exercise 12. And I had a request to just do some, it's on page 34, to do some problems with the subtraction to demonstrate the different ways you could do subtraction with the mental math. And I know that this is frustrating, and I also know that they don't give you any room to work it. And so certainly you would want to have it written down on another piece of paper for your child. You can just write it down for them. Matter of fact, you know what? I've done this in other places. I will put a PDF online that you could download and that gives them room to solve these problems so you don't have to rewrite them yourself. How could you solve these problems mentally? Remember, mental math doesn't necessarily mean that you're not going to write anything down. It just means that you're handling numbers in your head. And then the more things that you do in your head, really and truly, the more you will be able to keep in your head next time. So when I look at this, I think of the fact that if I subtract 101 first, then I'm down to an even 9,000. I don't have to take away 2,759. Now I only need to take away 2,658 because I've already taken away 101, right? If that is a confusion for your child, draw a picture. This is my box with 9,101 marbles in it, and I'm going to take away 2,759 of them. But if I go down to an even 9,000, that means I've taken away 101. So I've already taken away 101 of these. Down in this area that I still need to take away is only 2,658. Now, if that still doesn't make sense to them, let's make it even easier, right? If I start with 25 and I want to take away 15, I can say that's the same thing as 20 of them, take away 10 of them. The more you make it concrete, something they can keep in their head, something they can understand, count on their fingers and toes, count with marbles and blocks, whatever, the more concrete it is, then you can take it to a more abstract concept with numbers that they can't grasp with their fingers and toes, right? And then we can stop drawing the concrete picture and move to an abstract math problem. But wherever your student is, start there. They may start back here with, I got to go all the way to numbers I can think about and go from there, and that's fine. They may already be ready to handle this. That's great too. Wherever they are, go there with them. Okay? So then, again mentally, I would do 9,000 minus 2,000 is 7,000, and I still have to take away 658. Now, when I look at an even 1,000 minus 658, remember the trick that we have to make 9s out of everything and a 10 out of the last one. 658 needs 342 to make 1,000 because 8 and 2 is 10, carry the 1, 5 and 4 is 9, but I have a 1, makes 10, 6 and 3 is 9, but I have a 1, makes a 10. So think about these 7,000s. Each stick represents 1,000, but I'm going to take one of these thousands and take the 658 out of it, and that's going to leave me 342. So I have 6,342 as my answer. Personally, if I were doing this, I might write down on the side somewhere 2,658, just because by writing it down, it helps me not to lose the numbers. So if I mentally subtract 101 and write down 2,658, then I can look at 9,000, subtract 2,658, and I can come up with 6,342 as my answer, and that works out easily for me. I'm just going to go ahead and do the across problems. So that means answer C, 8,290 minus 4,986. When I see this one, because this number is awfully close to 1,000, my inclination is to use a different skill. I like to say that I'm pulling something out of my math toolbox. If I take away 5,000, I need to put 14 back. I can do that. 8,290 take away 5,000 is easy. That's 3,290. I have to put 14 back. Maybe a little complicated because I've got to round the 100 and go over the other direction, but I have 3,304. Because I'm taking away close to 5,000, I would do it that way. For the next one that is across, letter D, 6,000 minus 486, that answer jumps into my head. I have 5 thousands, and the last thousand I'm going to use to subtract 486. So those 5 thousands are still intact, and I need 514 is what I have when I take 486 out of an even thousand. F says 9,400 subtract 6,869. Again, just because it seems easiest to me, the first thing I would probably do mentally, I always try to change colors when I do a mental something. This is in my head, 9,000 minus 6,469. And so I know I'm going to have 2,531 when I subtract those. Again, whatever you need to write down in the middle, they will get to writing less and less down. For me, I didn't start this when I was little. I still would probably have to write this number down, and then even without writing this down, I might not write that down. I just might make a little note on the side of my page right there of that number, and then I can subtract. I know it's 9,000. I can think about 9,000, subtract that, and then I can write down the answer. So, but whatever they need to do. Taking a few steps is not a bad thing. I'm not sure that I'm going to have any new tricks for you, but let me just keep doing them just in case it's helpful. Maybe, okay, let me try this trick. Think of this as 4,102 and that extra 1,000 that I'm going to subtract 897 from. Because 897 out of 1,000, again, is pretty easy. That's 103. And 4,102 plus 103, 4,205 is again a pretty quick way, and they will get to the point they don't have to write that down. They'll be able to look at this number and think, I need 103. That's from 4,000, so the 103 and 102 is 205, and I'm only starting with 4,000. Honest and truly, that becomes a mental math problem. J, 6,400 minus 4,439. You could think this, I have 6,400s and I'm taking away 4,400s. That leaves me with 2 2000s, and I still have to take away the 39, so that leaves me 1,961. Another way to look at it. Take hundreds, subtract hundreds, and then again from an even 100, I'm taking away the 39. Those are the down or the across ones. Let's look at the down. Back up to A. This is going down. Now, preferably your students don't fill the numbers into the top yet. They do that at the end, and that checks their work, and then they're like, oh, I got it right. Otherwise, they're only doing half of the math because they don't really have to do it. They don't have to do the math because half the problem is done for them because they've got a lot of the answers up there. Okay, so how would you do this? Again, I probably would gravitate towards doing 6,032 add 222, which is, my thought process on that was to take that to 6,300 or 6,032 and another 1,000 and take away the 778 out of 1,000 to get 222. And even just thinking that in my head, if I look at this number and know that it's 222, and I can add 222 here and get 254, almost said 7, That wouldn't have been good. And my thousands are now down to 6,000. Do you see how you begin to think about them that way and becomes mental? Part B, 8,070, subtract 5,635. This is so close to 70, I'd probably take the 70 away, which is not necessarily easy here, right? Except if you realize that 70 is 35 and 35, that makes it fairly easy. 5,565. You can think I have 63 tens. I'm going to take away 7 tens, and that's going to give me 56 tens. So the 5,000s isn't changed, the 5 ones isn't changed, but I have the task of subtracting 7 tens. And so if you think about 3 and you've got to borrow and carry, that makes it a little harder. If you think about 63 and take away 7, you take away the 3, you got to take away 4 more. And so then 8,000, take away 5,000 is 3,000, but I'm going to use one of those 3,000 to subtract the 5,065. So now I'm down to 2,000, and I've got to make 9s. 5 and 4 make a 9, 6 and 3 make a 9, 5 and 5 make a 10, 2,435. D, 7,968, subtract 2,240. If you look really carefully and you don't always go to the hard stuff, you might realize this is a straight subtraction. Isn't that beautiful? Does that just make your child happy? 7,000 minus 2,000 is 5,000. 9,000 minus 2,000 is 7,000. I'm sorry, 100. 6 tens minus 4 tens is 2 tens. And 8 ones minus nothing is 8. Hopefully they always look for that just a passing glance, just in case they throw an easy one at us, so we can just plain old subtract. Letter E, I think when they're so close to an even thousand, it just makes so much sense to go down 5 for both of them. So 4,000 minus 2,673. Again, 4,000 minus 2,000 is 2,000, right? I'm going to subtract the 2,000, but this 673 has to come out of that other 1,000. So I have 1,327. Again, I have to make 9s with everything else, except for the 10 with the 7 to get up to 4,000. Everything else is going to be a 9. 1,327. G, 7,533, subtract 4,492. I would probably look at this and realize that this is close to 500, and I do have 500 here. So I would subtract 500. I'm sorry, I would subtract 4,500, right? So that gives me 3,033, and I need to put 8 back. If I subtract 4,500 and then I put 8 of them back, that's the same thing as subtracting 4,492. So 3,033 plus 8 is 3,041, and that is the answer to part G. Last one on H. 8,144, subtract 485. We could subtract 144 on this one. For some reason, my mind goes to taking 1,000 plus 7,144 and subtracting 485 from that 1,000. Again, I need 515 and the 7,144 gives me 7,659 for an answer to that one. Not one way is the right way to do it. What we need to make sure is our kids have a really full toolbox, lots of different ways to do the problems, lots of different options, and solve them that way. That is all of that page. Hopefully that was helpful to you.